or weight. Third system is seconds, basically used to measure time. Third, Fourth one is ampere, which is used for the current. Kelvin, basically used for the temperature. Mole is used for the molecular weight, and candela is related to the light. The second system is SI system is derived units, which are basically derived from the base unit systems. So work or energy is derived from the base units, which is measured in joules. The power, the rate of doing work, so which is measured in watts. 1 watt, basically we all know 1 watt is equal to 1 joule per second. So any system having atom. So the basic atom arrangement is like this. In atom, free electrons and protons and neutrons present in any atom. Okay, all the element having the three basic elements: orbit, electron orbit, which this is the path where the electron is traversed around the nucleus. The electrons are always rotated around the nucleus. In nucleus, proton and neutrons is present. Depends upon the number of electrons and protons and neutrons present. Every element having their own physical and electrical characteristics. The base unit is charge. Charge is the electrical property of the atom particle of which matter consists of, measured in coulombs. Okay, so which is denoted with the Q, either capital Q or small q, measured in coulombs. Charge is the smallest charge in the electric system. So the electric charge is numerically minus 1.602 into 10 power minus 19 coulombs. A proton having the opposite charge of electron, which is plus 1.602 into 10 power minus 19 coulombs. In the most circuit, the charges in the motion are electrons. So depends upon the motion of the electron, the material electrical characteristics depend. Charge is conserved, means as like energy is conserved, conservation system, energy will neither be destroyed nor be created. As like charge is neither be created nor be destroyed. So let us we discuss basic units of the basic definitions of the basic electrical engineering, in which first definition is current. What is meant by current? The rate of flow of electron in a conductive or semiconductive material. The root cause happened because of the electrons. The electron movement is called as current. Let us consider a particular cross-sectional area of a wire A. The length of the wire is small l. The time in a time but consider t in which the charge is passing particular area is treated as a current. So current is the rate of change of flow of electrons. Mathematically, it is represented as I is directly proportional to dq by dt, where dq is a small charge with change respect to the time. So 1 ampere, let us, what is meant by 1 ampere? 1 coulomb. 1 coulomb of charge per a 1 second. The current is rate of flow of charge. We already discussed. The current must be distinguished with both a direction and a magnitude, because if the current is flows in a direction, particular direction, it treated as, if let us consider 3 amperes. For example, in the same wire, the current is flow in the opposite direction, that is treated as a minus 3 amperes. So current is a vector quantity. So the diagrammatic representation of the current flow in a circuit. So next, fundamental definition of the voltage. What is meant by voltage? We all know the work done on a charge, which is in physics. Whereas in electrical engineering, the potential difference between the 2 points. Okay, let us consider A and B are the 2 points. Okay, if charge is present at A point, which is moved to B point, we need to do some amount of work. That work is called, that work done on a charge is called voltage. Okay, so the potential difference is denoted with V, V between A and B, A suffix and B. Okay, if we consider dW is a small change in energy dW, and small change in the charge, which is denoted as dq, is also called as voltage, or potential difference between the 2 points. Okay, basically which is measured in volts or joule per coulomb. How the work is measured in joules, charge is measured in coulombs. Okay, in below given diagram, if the potential difference between A and B is 9 volts, see the polarities: positive at A point, negative at B point. If the reverse the polarities, negative at A point, positive at B point, it is treated as a minus 9 volts. Okay. So next definition is power and energy. What is meant by energy? It is a capability of doing a work, or it is a capability for doing work. Okay. So basically it is denoted with E, and basic units are joules. What is meant by power? Power is a rate of change of energy. Okay, it is mathematically denoted with the E by T or W by T. Okay, so basically it is used with units as watts or joule per second. When the power is positive, the element is absorbing energy. What is absorbing power? What is dissipating power? We will discuss in further classes in detailed manner. When the power is negative, the element is supplying the energy. Okay, so basically the power is the rate of change of work or energy. So mathematical representation of the power, P is equal to dW by dt. Means dW by dt can be written as like this: dW by dt will be written as dW by dq, as an intermediate value dq by dt. We all know dw by dq is treated as voltage and dq by dt is treated as current. Okay, see the difference between the observing power and delivering power. If the current is entering to a circuit from the positive and leaving from the negative, that power is called positive power. If the current is leaving from the negative symbol and entering into positive, that is treated as the negative power. P power is equal to minus V into I. Okay. So now let us discuss the basic circuit elements. What are the elements we need to learn to master in the basic electrical engineering? So now we are seeing the classification of the entire elements. The first one is active elements. The second is passive elements. What do you mean by active elements? Active elements like a sources which are giving the energy continuous to the circuit. So that are called active elements. Passive elements means they can store but they can't give the energy to the circuit without help of the active sources. Or passive elements also can be defined as they are dissipating or energy losing elements. Okay, in which basically passive elements having the three elements we need to learn. First one is a resistor, which is denoted with the capital R. Second one is the inductor, which is denoted with the L. Third one is capacitor, which is denoted by C. In active elements, there are voltage sources and current sources, in which there are furthermore two classifications. First one are dependent sources. Second ones are independent sources. Depending upon their energy level, they can deliver independently. The elements are called as independent sources. If the energy deliverability is depends upon the independent source, they are dependent sources. In dependent source also, there are two more classifications. First one is voltage sources, second one is current sources. In voltage source also, there is furthermore two more classification, in which ideal voltage sources and practical voltage sources. In current sources also, there are two more further classifications. First one is ideal current source, second is practical current source. These ideal practical current sources, ideal voltage sources, current sources, we'll discuss in detail in future classes. In dependent source also, there are four more classifications: voltage control voltage sources, voltage control current sources, current control voltage sources, current control current sources. Okay. So previous slide we seen how they classify depends upon their deliverability of the energy. So active sources, what are the active sources? In which there are further two classification, voltage sources and current sources. These are the voltage sources, these are the current sources. Okay, the basic symbol representative of the voltage sources. We can represent as voltage as circle as positive and negative with the voltage of the strength. Otherwise, this is a DC voltage source. We can represent as a DC source or battery as like this. And third one, AC voltage sources. Okay. In current sources, represented as in circle with arrow button, arrow symbol. So basically, we are having the two types of currents. First one is DC current and second one is the AC current. So this classification depends upon the magnitude change with respect to the time. In DC currents, the magnitude is constant irrespective of the time. DC means direct current. Okay. So AC means alternating current. Alternating means their magnitude varies depends upon the time. So it is a time varying magnitude. So dependent current sources. So basically these all are dependent current sources, current or voltage sources. Why? Because it is called dependent source, basically represented with the diamond symbol. If the voltage source is, it is positive negative symbol in diamond. If the current source is denoted symbol as diamond inside the arrow. Okay. So basically, if the voltage is a parameter, dependent parameter, the voltage is independent parameter, dependent parameter. Based upon this, they are classified dependent voltage source and current sources. If the voltage is depends upon the current, means function of current. This is treated as the current dependent voltage source. Okay. Similar manner, if the current is depends upon the voltage, it is treated as voltage dependent current sources. So we learn in probability and statistics or permutation combination, there are two different combinations, voltage and current as two parameters. We can arrange like this: voltage and current, one voltage dependent voltage, current depends upon the voltage, or current is depends upon the current. So based upon these four combinations, they are differed with their quantity and magnitude. Okay. So what is meant by Ohm's law? So basically Ohm's law states that the voltage across a resistor, okay, is directly proportional to the current flowing through the resistor. Okay. So that voltage flowing through a resistor is V, voltage across the voltage resistor is V, the current passing through the resistor is current I. Time being, the resistor symbol is denoted as like this. The voltage across resistor is V, the current passing through the resistor is current. So which is proportional to according to the Ohm's law at constant temperature. Keep in mind, the Ohm's law works at constant temperature. It is very important to understand Ohm's law. Okay. So we all know, to remove the proportional constant, we can write as V is equal to I into R. Okay. So R can be written as V by I. So what mean by resistance? The resistance actually, it is a ability to flow of electrons means current. So but it is opposes the flow of current is called as resistance. It is a basic nature of any element in which having the which opposes the flow of electrons is called resistance. Okay. Let us consider a wire length of L having the area of cross sectional is A. So the resistance is always proportional to the length of wire. The resistance is inversely proportional to the area of cross section of the wire. So R we can write as directly proportional to the L, inversely proportional to the A. In order to remove the proportionality constant, R we can written as R is equal to rho LA by A, where rho is resistivity of the material. Okay, this is the circuit symbol of the resistance. The I is the current flowing through resistor. The voltage dropped across the resistor is V. So we all know coordinate system. If V is considered as on y-axis, I is considered on the x-axis, the points of voltage current and voltage coordinates give a line which is passing through the origin is slope. So that gives the value of the resistance. This is the VI characteristic of the resistance. We all know the reciprocal of the resistance is called conductance, which is denoted with the C. I forgot to mention the resistance is measured in ohms. So ohm symbol is denoted as like this. Okay. So the reciprocal of resistance is called conductance, which is denoted with capital G. The mathematical representation is G is equal to 1 by R. We all know R is equal to V by I, whereas G is equal to I by V. So basic unit of the conductance is Siemens, 1 Siemens. So Siemens symbol is as like ohm, which is oppositely as like ohm. So 1 Siemens is equal to 1 ampere per volt. So these VI characteristics, the V characteristic, or give a non-linear resistance because it having a different slopes at different points, whereas in A graph having the proportional with respect to each parameter I and V. So we will come to learn the what is meant by open circuit, what is meant by short circuit. So in this diagram, this is a circuit. Okay. So what is meant by circuit? Basically, we come to learn, come to know what is meant by circuit. It is the interconnection of the elements. Okay. So let us consider this diagram. In circuit, if resistance is zero, means which is sorry. If the resistance zero, I'm sorry. So now we will discuss what is meant by open circuit, what is meant by short circuit. Short circuit means if it is a wire, there is no resistance, means R is equal to 0. It is treated as a short circuit. Certain wire break down between the 2 points. So physically open means it is a open circuit. In terms of resistance, the resistance is very large, which is nearly infinity, it is treated as a open circuit. If the resistance is very low, ideal cases resistance is 0, it is treated as a short circuit. Thank you everyone. I hope everyone understood on this topic.